Now that we've covered the concept of forces, now we're ready to move on to mass and Newton's laws. I want to start with the concept of mass, because mass is very important to all of Newton's laws, and it's very important that we understand it. And mass can be a little confusing at first, and this is partly because it's often easy to confuse this with weight. And part of the reason is we actually have a conversion factor of 2.2 pounds equals 1 kilogram. Now, as I've mentioned in previous lectures, this doesn't make a lot of sense. Pounds is weight, but kilograms is mass. So why do we do this so often? And this is because mass actually does two things rather than one. First, mass resists acceleration. Now, that sounds a little confusing, so let's figure out what we actually mean by this. What we mean is it's harder to accelerate, it's harder to speed up something that is high mass rather than something that is low mass. And you've noticed this if you've ever pitched a softball or bowled a bowling ball. It's about the same motion, but a softball, which is much smaller, much less mass, you can get it going much, much faster, 60 miles an hour or more. Whereas a bowling ball, which is much bigger, is much, much slower and just rolls down the lane. And as a result, we can see that the greater mass of the bowling ball is really big, creates a small acceleration. Big mass, small acceleration. Whereas the little mass of the softball, small mass, allows for great acceleration, which translates into great velocity. However, this doesn't explain why pounds and kilograms can be seen as the same thing. So now we need to see our other function of mass. Mass also causes gravity. And this means that the more mass something has, the more gravity it produces. And the more mass something has, the more it's affected by gravity. And this is why things feel heavier. When you feel something heavy, that means it's exerting a force on your arm because of gravity. So going back to our softball exerts a small force because of its small mass, whereas the bowling ball gets a much larger force exerted on it by gravity because of its larger mass. Now what this means is pounds, which is weight. Weight is just force exerted by gravity. So weight is force exerted by gravity, and mass can be resistance to acceleration or the amount of gravity that something will cause. So as a result, something that has a lot of weight, is affected a lot by gravity, is also going to have a lot of mass. And as a result, we can actually convert back and forth, even though it's not really accurate, they're not really the same units. And if you actually wanted to convert to the right units, the units of mass in the English system is slugs, but it's such uncommon to use the English system for actual physics that we'll almost always use kilograms for mass, and if we ever need to get a feel for it, we'll just convert it back into pounds to get an idea of what's going on. And just for the record, 2.2 pounds to the kilogram. Now the very odd thing is we've known for hundreds of years what mass does. Isaac Newton, one of the most famous physicists of all times, actually came up with both of these ideas. So this is Newton up here, and he actually conceptualized both the understanding of mass as it relates to acceleration and mass as it relates to gravity. But the thing is, even now, we don't totally understand how it works. We understand what it does, but we don't really understand what causes gravity. There's been various theories. It's been talked about as being caused by the curvature in space-time and a variety of other very complicated things that really very few people understand. And the same with mass and acceleration. It's been argued that mass may be caused by the Higgs boson, a particle that was discovered recently. But once again, very few people understand exactly what that would mean. And in the end, what causes these things is very complicated. It's one of the great unsolved mysteries of physics, and if you ever become a physicist, maybe you'll be the one to find it out. Now, the other important mass-related concept is called the idea of center of mass. If you've ever balanced a pencil on your finger, you'll have noticed this. There's a point on the pencil where you can put your finger directly under it, and it'll balance perfectly. And the reason is when you do that, your finger pushing up on the pencil is exactly lined up with the force of gravity. And we can say this because instead of imagining the force of gravity coming from every single point on the pencil, we can imagine that the point of force of gravity comes from a single point, called the center of mass. And this is the point where all the other forces cancel out. And we can do that with a number of other things too. If you're throwing a ball, we can imagine that you're exerting a force not on the entire ball, but just on the center of mass. And it's this kind of approximation that lets us imagine all of the things in physics as if they're just single points. And we'll change this assumption a little bit once we get to things that are rotating. But for now, you can just imagine any object as a point with a number of forces radiating out of it or pushing into it. And this assumption does make our calculations a little less accurate, but it also makes our calculations much, much easier. And a lot of physics is understanding when you're allowed to make calculations less accurate in terms of making them easier. So throughout all of physics where stuff isn't rotating, you can just assume that all masses are point masses, masses that are just a single point, and do your calculations accordingly. So hopefully you now have an understanding of what mass is and are ready to move on to Newton's laws.